Hi everyone, welcome back to our channel. Today we are going to do the practical experimentation of Z parameters as well as the Y parameters. So the Z parameter network given to us is 820 ohm and 510 ohm and 2 kilo ohm. This is a T network. Okay, so the given network is an T network. For this T network, we need to find out Z parameters as well as the Y parameters. So see here, coming to the circuit diagram. So through RPS, this is the RPS. This will measure the voltage V2, and this will measure the current I2, and this voltmeter will measure the voltage V1. So when you perform it, then automatically when you make I1 as 0, then we are going to get Z12 value as well as Z22 value. So Z12 is V1 by I2 as well as Z22 is V2 divided by I2. Then we can find out Z12 as well as Z22. And when you make I1 is equal to 0, then you are going to get Z11 value as well as Z21 value. This is V1 by I1, and next one we are going to get V2 by I1. So these are the basic formulas. When you see the two port, then you can understand. Okay, so coming to the circuit diagram, so output port we need to excite and connect to the ammeter. Okay, so output of the ammeter we are going to connect. Okay, so here we have the RPS positive, connect to the ammeter positive. This is one wire, and the next wire will directly go to the port. Okay, so next wire will go from ammeter output to the port. Okay, and we are going to have the negative wire where we are going to connect from negative to negative. So this is like a closed path. So from regulated power supply, it directly goes to the ammeter, and output of the ammeter it goes to the board, and output of the board it goes here. So therefore V2, I2, and we want to measure V1. Okay, so now we are going to give the supply. So now we are applying the voltage at output port. You can see here I kept in channel 2. Why? Because this is channel 2, and the process of starting is initially current should be in maximum position and voltage should be in minimum position. Okay, so slowly as soon as you keep the current in maximum, both the channels you have to keep it in maximum, and slowly we have to increase the voltage. Okay, so already I kept in maximum, and the voltage is at channel 2 is 30, and when you come to channel 1 it is 28. So no need to bother about channel 2, just I am using only channel 2. So at channel 2 voltage is 30 volts, so I had given 30 volts, and this is the current I2. So now we are going to write down the tabular columns. So V2 what we are applying theoretically is how much? 30, and practical also we are getting V2, and the current in the network, which is nothing but I2, we are getting approximately 10, 10 point, I mean 11, 11.5, 12. So we are going to get here as 12 milliamperes, and the voltage V1. Here how to write down the V1 is very important. How to write down V1 is, so here it is open. As soon as it is open, so this branch is open. So current is 0 and resistance is 820. 0 into 820 is once again short circuit. I mean this will act like an short circuit, and we need to measure this voltage. So for this negative I am connecting to negative, and I have the positive here, and this positive I am connecting to the positive of the rheostat, and negative I am connecting to the this terminal. So this will indicate the voltage, and this voltage is approximately 6 volts. You can see here the V1 is 6 volts. Okay, so now when you write down V1 is 6 divided by I2 is 12, then automatically you will get this in kilo ohms. This is nothing but we will get Z12 parameter, and Z22 you are going to get V2 is 30 and I2 is 12, then you are going to get Z22 parameter. That's how to evaluate Z12 and Z22. Since it is in milliamperes, when it goes up, you will get in kilo ohms. This is how to make input as open circuited, finding Z11 as well as Z22. Now we want to make output the open circuited output. Output side you have to perform open circuit. Okay, same. So just I am removing the supply and turn off the supply, change the excitation. Okay, so here I am giving the input to the input port, and now I am exciting this side. Okay, so you can see here. So the same network I am shifting to input side. and I am measuring the voltage at output side. This is the voltmeter. Okay, now we can see the connections of this diagram. So now we are giving the voltage at port 1 and we are measuring the current. Okay, so therefore how we are going to get is, this voltage is V1 and this current is I1, and here it is open automatically, I2 is equal to 0. So 0 into resistance, automatically this will also act as an short circuit, and this voltage will get it as V2 voltage. So now how we are going to get, let us try to see here. So from the positive terminal of the supply, I had connected to the ammeter positive. Output of the ammeter I am connecting to the board input. So now this will act as an V1 and this will act as an I1, and you see here this is open circuited. Okay, so whenever output is open circuited, current is 0, current into 2 kilo ohm will act as a short circuit, therefore the voltage becomes 0 here. So just give the supply. Already I kept channel 2 in 30 volts, so now channel 2 is of 30 volts and this is nothing but the current. Okay, so now we are going to find the three values where this is V1, where this is I1, and we want to measure the voltage. So to measure the voltage, the positive I am going to connect at the positive terminal and the negative I am going to connect at the negative terminal. So now you see here what are the parameters we need to write down. So this is nothing but V1 we are applying. V1 how much we are applying is 30 and we are going to get I1. So I1 is 20, 22, 24, sorry. So this is 20, 21, 22, 23, 24. So you are going to get the I1 current is 23 milliamperes and we require the V2. So V2 means is output voltage. You see here the voltage I already told, when you make as open circuit, current into resistor, the voltage is how much? 0. So now when you connect a multimeter for this resistor, it is showing that 0 volts. 0 volts means now this resistor is acting like an short circuit. Therefore if you measure the voltage from this point to this point, you will get the V2 voltage. Now this is how much? 11 volts. So therefore you are going to get the 11 volts. So 11 volts we are going to get. So you see here if you connect at this point also it will be same. Why? Because the voltage at this point or this point both are same. Why? Because this resistor is short circuited. The voltage across 470 ohm will be the voltage V2. Why? Because this resistor is short circuited. This is how to find out the parameter Z11 and the parameter Z22. So now from the practical we had got V1 is how much? 30 and I1 is how much? 22 milliampere, and move it to and it will be expressed in kilo ohm. So coming to the Z21, so V2 value is how much? V2 is 11.2 volts and I1 is 22 milliamperes and you will get the value in kilo ohm. This is how to find out the Z parameters for the given T network. You can do the theoretical calculation. I will leave in the card the theoretical calculations of Z parameter we can see in the card. And similarly we are going to find out the Y parameter. This is also same structure of finding Y parameters.